Well, hi everybody, and hey, welcome back to my shop after the big power outage I've been through the last 5 days. Actually, the power's been on for a couple of days now, but I'm just getting back into my shop. Too preoccupied with other things, including celebrating Christmas late. But you know what? It all kind of worked out. And part of the reason why it worked out here for me is because I was able to provide myself backup electricity, and that's what we're going to spend a little bit of time talking about and looking at. And I'm going to be making some repairs to my UPS, which is just sitting right there in that funny angle with this guy here. So the way I survived was a combination of UPS and one of these, you know, and this is just a 500 watt inverter, and you plug it into your car, cigarette lighter style plug, and then out comes 120 volts, and this one will kick out 500 watts. It has a fan in it here. In an ice cold vehicle, this thing's probably good for a lot more than 500, but it has automatic circuits to limit it. And it's limited two ways. One is the truck battery voltage drops below a certain amount, and I'm not sure it says what the amount is, probably 11.5 volts or something like that. It shuts off, and that's supposed to preserve your battery so you can always start your vehicle. It doesn't work. And the other one is if you, well, this is only 375. Huh, I thought this was a 500 watt unit. Okay. But out there in the cold, it would do more, but I think it will limit itself. Will automatically shut off when the power drain gets up around the rating. Wow, I didn't realize this. I thought this was somehow more powerful than this guy. This guy over here. Let me get him, actually. What this is a ordinary office UPS computer backup power supply. There's lots of different ones around. They have a battery in them. But there's no battery in this one. In fact, I'm not even sure where the battery cover is, to be honest with you. And this guy produces 500, it says volt amps, so that's pretty much 500 watts. It's kind of a way of indicating it's really limited not by the power but by the current that comes out of it. And I went and cut this wire off the power cord, and I've reconnected it now. And I also cut the battery input power cord. And why would I do such stupid things? Because I shouldn't have. It's going to get rid of this one. This one has a beeper in it, and it just beeps the whole time it's operating, because what it's really telling you is, come shut down your computer or I'll be out of here in 10 minutes. So it gives you 10 minutes to do your computer shutdown. Of course, I got this thing hooked up to 2 car batteries in parallel. And I got almost 20 hours out of the first car battery. With what a fairly small load I had on it. That's pretty darn good. The 2 in parallel will give me probably 30 hours, maybe more. Depends what you're doing, of course, with the power. But who wants to listen to this thing beeping for 30 hours? It's not going to be fun. So I thought I'd get rid of this one. I have another one. I'll use the other one. But you know what? The other one doesn't work. I discovered tonight when I got it all set up. So I had to resurrect this one out of the garbage, put the cord back on it. And now I'm going to go inside this UPS and get rid of the beeper. It's not easy to separate it. And I'm just looking for it inside there. Oops. Got the camera balanced just a little bit precariously here. Let's look at the other side. Oh, this opens up easier this way. Should be pretty easy to spot the maybe a transducer would be the proper word for it. Oh, those curious things. And there's some fuses inside here. You know, it has a breaker. That I would say is a relay. Where's the speaker? I may have to fire it up to hear it. Because, wow, it's not, I thought this would be real easy. It's definitely not mounted up in the top. I'm looking it over awfully carefully here, because I don't want to just simply have overlooked it. Oh, there it is. I see it. I was overlooking it. There it is right there. Right there. Okay, let's see how we can disable this thing now without... Disable it or quieten it. I think disabling it would be the best thing. Could leave it in the circuit and just destroy the disc in there, but it might just turn it into an ugly buzzer. Could drive a screw down into it. That would probably stop the diaphragm and silence it. It would also leave it in the circuit again. So why don't we do that? Because that sounds like the easiest and easiest way of doing that. Otherwise, you know, I'm lifting the board up and unsoldering it, and you know, that's gonna, it's gonna take me a lot more work. And lazy is the day. So here's what I'm doing with these. This is what I'm doing with the UPS, really, because the UPS is in standby mode and ready to come on as soon as the power disappears. Whatever you have plugged into it stays on, which is normally your computer, but I'm not too interested in trying to power a computer. I'm powering my internet connection. So the modem continues to operate. Now I've learned from, we have to fit this and see if that screw is going to interfere here. Yikes. A little shorter screw, please. I don't think I'm comfortable with that long screw sticking out of there. Maybe that'll do the trick. And now, you know, I'd have to wind back my own video here and see what the heck it was I was talking about before I got distracted. Oh yeah, what was I doing with these things? Here we go, just grinding it in there. Oh, that's stupid. I can't tell anything. I managed to rip the top open. Okay, this smashing thing looks good to me now. Well, won't be hearing any beeping now. Maybe that was even easier than the screw. Ripped it out of there. It's gone. Gone from the circuit board. So no more beeping. So I keep my internet connection live and operating because we have, like lots of people, we have tablets. We have a couple tablets. We have telephones that use Wi-Fi, and a laptop. And all these things have batteries. Oh my gosh, I got it back together. Stunning. Well, almost together. And so, believe me, when and we also have a lot of radios, of course. So we have an AM radio playing. I'm sorry, AM FM radio playing. And if we can keep our internet connection going, well, our lives pretty much keep moving forward. So in a short-term power outage, I'm able to run a couple of lights, and nowadays I'm running 10-watt CFL lights, and they put out a lot of light. You know, when you don't, you know, when you're in that situation, there's plenty of light coming out of the house. That's just 20 watts for those two bulbs. And what am I going to do here now? What a knucklehead I was to cut this stuff away, you know. I didn't have to. Jump the gun. So I think what I'm going to have to do though is cut them here and connect on the lead wire that can go up to the batteries. Doesn't have to be very long. One of the mistakes I had last time was I set it up with very long lead wires, because I thought the batteries were going to be in one place and the UPS in another, and then they ended up side by side and had all this extra wire, and I never cleaned it up, so now's my chance. Yeah, we'll use some of this wire. I want fairly heavy wire because it's drawing power at 12 volts, so it's a fairly heavy amperage. Relatively speaking, it's a heavy amperage. So what we'll do is we'll use we'll just use about that much, not very much at all. Okay, so I've told you that I kept my Ethernet operating by keeping my wireless modem going. And luckily, the internet signal never went away, even for 5 days of a power outage. Our Wi-Fi was working the whole time. So, I'll use these. But that's not enough. Because it was really cold, minus 10. The one night there was minus 16 or 17 Celsius. It's pretty darn cold. I had to take further action, so I needed a little more power. Well, there's two problems actually. I mean, if you're going to go 5 days on a UPS, you need a battery with how big? You know, gigantic battery, which you cannot have. They just aren't around, practically speaking. So I'm using car batteries. That's a little crazy too, most people's perspective, I would think. If you really want to protect yourself for like a week, just using batteries, oh my god, you need a lot. It's not practical. So what I do is I make use of my automobile. Actually, I have two. I have a car and an SUV. Where are my cutters? I don't get that. Two pairs of cutters have disappeared in front of me. And these ones, the teeth, the cutting blades don't meet up very well. So anyway, I use my automobiles. I'll take one of these kind of inverters. So I put it in my truck. Let it run on the battery. That gives me a little more power. And opened up the opportunity for me to operate my furnace. My regular house furnace. Not with 375 watts. That's not enough to drive the furnace and the furnace fan. I never did operate the furnace fan. So nevertheless, I put this out in my truck. Run a regular extension cord, you know, in my lawnmower extension cord into the house. Power bar and extension cords here and there. And the thing about it is, you know, my car is going to last a long time because I can always start it up and charge the battery, which is what I did. And then to ensure that I never drain both vehicle batteries, which I almost did when I first started doing this, I connected the inverter to one vehicle, and it was always on one vehicle, and I'd run the inverter with all vehicles off, and when the inverter finally drew down the battery voltage far enough and shut down, I'd go out, start up the other vehicle and jump it to the first vehicle battery. I'd never start the first vehicle. I'd never bothered. That way the second vehicle was always fully charged, and then I would leave it running for quite a while, by the way, because when you start up the car, of course the extra voltage means you can draw more power from the inverter without worrying about drawing down the battery voltage and tripping the limit. So I ran my car quite a bit, quite a few hours. But you know, my neighbor had a generator going, and really, how different is it? Of course, a generator is a smaller motor, generate more electricity. I mean, there's no doubt about that. His was a 2,000 watt generator. If I had a car running in my driveway, he had a generator running in his backyard. Okay, let's put a little solder on that. I forgot to put on the... we'll use tape. I was going to use shrink sleeve. We'll just tape it. I guess I got more than one of these inverters, so perhaps I could put two of them out there and get double the wattage. So, you know, at that point you have a fair bit of power for running a lot of simple things. And another thing I learned, and this really surprised me, maybe it won't surprise you, it's difficult to charge cell phones and things like that. The chargers draw a lot of power, and I'm still got to investigate this a little bit further. I want to know what's going on there. I didn't think they drew that much power, but every time we tried to charge our phones off this system, and the system was loaded too. I mean, it had some stuff on it along, not just these phones being charged. It had lights and stuff like that. We'd overload it. We're shut down. So I got to investigate this, because I do want to be prepared if we end up in this kind of a scenario again. Yeah, you know, I'd encourage anybody who's got any handiness at all with electricity, I mean, even minimally, frankly, to go and get an inverter. They're real cheap. I don't think they cost much at all. Just get a, you know, low power inverter. Sorry about that. I'm just making a mess here. Okay, you want to see a close-up of a real life paint job being done? Let's do this. It's because my blades don't meet. Where are my other cutters? Like ripping them out of there and cutting them. Now I was lucky in this house. We have a gas water heater. It's not high efficiency. It requires no electricity. Same old style water heaters. Gas water heaters been around for ages. So it continues to run without electricity, and there's just no need to do anything. There's a source of hot water, substantial amounts of hot water, you know, get out of our hot water heater. And we also have, sorry, I'm a bit of a slow talker here while I do this. So I'm trying to concentrate on what I'm doing while I tell the story. I'm afraid my brain can only handle one thing at a time, it seems. Because this went on for 5 days, it was really important that we get a good supply of heat, and hot water is just not going to do it out of a hot water heater. You can't heat your house that way, although you can help, definitely help. So I was able to fire my furnace. Now, my furnace is a little unusual. It's old. I think most people would be very unnerved to have a furnace of this age in their house. My furnace is from 1965. It's just a regular, I think they call it an atmospheric gas furnace. Nothing special about it, and because there's nothing special about it, I was able to operate it with just a little bit of power. And I don't mean the fan, I mean the burner. And I'm certainly not recommending this to anybody. And who would have a furnace this old anyway? Because I'm pretty sure the more newer furnaces, you absolutely cannot, should not attempt to operate them. But mine, since it has no blower and stuff like that, it's atmospheric. It's not as risky a venture. You can make the burner go, the furnace, in terms of exhaust and all that, it's just going to work the way it always works. Not much much risk at all. So I simply isolated the burner control from the rest of the unit. It's really very simple to do that. Supplied 120 volts from inverter, and presto, the burner came on. And then you know, you may want. I did some videos when I was in this condition. I did some no power day 1, no power day 2 type videos, and sort of show some of this stuff that I'm talking about now. Yeah, it's not a very good tape job, is it? But frankly, I just don't care. Good enough. So to push the air through the furnace, because convection didn't work well in my case. My furnace is not a convection furnace anyway. It's forced air, like most gas furnaces are. And there is some convection through it, but you know, really not much. And so I wasn't going to get much heat out of the furnace and into the house unless I could blow air through it. So I got a regular house fan. I had a fairly big one that seemed to draw too much power. I used a smaller one, a regular tabletop fan, stuck it on the air inlet for my furnace, and plugged it into the inverter and let that run constantly. That's a fairly good load, probably 150 watts or something like that, somewhere in that range. I'm not sure, to be honest with you. Another thing I should look into. Okay, I'm going to turn on a vacuum here, so I'm going to back you away. So, yeah. Full blast. Bring you back in a sec. There. Just there. So you don't get any earful. Okay, so all I'm doing there is hooking up the power cord for the battery. Let's clear the other side, and we just have to connect this to the battery. Oh goody, I found one of my cutters. There's a better cutter. So the great thing about a UPS, just to go on to carry on, change topics, is a UPS charges the battery as a trickle charger. And so with this thing connected as up against my car batteries, which I charge with a big car battery charger, by the way, to get them up to charge, this thing will keep them charged. I don't have to worry about them. So presto, charge car batteries. And lots of, probably, like I said, 30 hours of use. So there we are. So those are ready. So let's see. How can I get you a view of this? Yeah, that's where I'm going to be working, but I really can't get my camera on a good angle for that. So I'm just going to complete the installation, and then I'll show you what I've done. Back in about once. Okay, now this is a little different view of what's in my my shop area. And this isn't usually behind me, so I don't normally have this on camera. It's a refrigerator, and you're on top of the refrigerator, 2 car batteries, and these are now connected in parallel, and they are fully charged. So it's a little dangerous to fiddle around with this without a little bit of protection, just in case we generate a short circuit. So I have some eye goggles on there, just to keep myself a little bit safe, you know, from the splash, from the spark. And our objective is to connect this wire. Now this wire, like most of these wires, one side of the insulation is smooth. Let's put this like that. Sorry for a sec. Should get with the lighting just a little bit better. Still a little too hot. I have a hard time with this camera. Okay, good enough anyway. So one side of the wire is smooth and the other side is ripped. I don't know if you've ever noticed that, but most cords are like that. So it's easy to figure out which wire is which at either end. And I put the red wire on the red side. Yes, I'm double checking. Don't want to make a mistake on this. So again, making sure I know which is which. You can also see these ribs with your eyes too. So the negative is a little bit longer. So we're going to connect the negative over here first. Now I'm going to be soldering this right in there, which is a little bit of a strong way of doing it, in a sense. The long one was the negative. Is the negative. I don't want to short anything here. Pretty sure. Let's solder this one first before I connect the other one. Pretty sure we won't hear any beeping, but the machine may come to life as soon as we connect the wires up. My solder. And what does come to life mean? May start buzzing a little bit or something like that. This is pretty much the extreme reach of my soldering iron. Okay. That's one connected. So again, this system is going to power my, that's my my home phone. I have an internet telephone system, and that's the modem for that. And it will also power my house internet connection. And that wireless modem is upstairs from here. But I have it's plugged in through extension cords to this location. Like here it is right here. It's running right now. It's plugged into this green extension cord, and that's just plugged in the wall. So it's running on regular unprotected power. I'll be switching it when I get this done. So a bit of a mess of wires up here. Okay, now this may cause it to come to life. Ooh, make me jump. What was that? Was that my imagination just now? Blow something up? Well, whatever it was. Maybe it was just a capacitor inside the UPS. The UPS has an on-off switch, but it's one of those ones you just push it again and again, and I think it's pushing a little button on the circuit board. It's not a real on-off switch, if you know what I mean. It's an imposter. And I'm pretty sure I'd have to push that button to make this thing come to life, but I was just a little nervous there. You might have noticed. I'm soldering this stuff up for reliability. I mean, there's some other better connections that could be made using, you know, like screw down connections and stuff like that. There we go. Put a lot of heat on that because there's quite a bit of wire there. Now these connections are not protected right now, so this is quite dangerous in terms of the short circuit on the car batteries, which I really would not want to see. Now, plug in the UPS. Oh, it's just about the big moment here. I have a really tiny, high efficiency shop. Just rolling a few things out of the way here. Yeah, tiny doesn't always mean high efficiency. There it is. I'm just plugging it in down here, okay? So we'll plug it in. There we go. Okay, it's plugged in. So we're plugged into AC power now. The hum, I think I might be hearing that hum. I'm not sure what I'm hearing. Might even be the refrigerator. So let's give it a quick test here for power. That's good. Okay, these are the ones that are the backup ones, and they're off. Okay, so we're going to turn it on now. Okay. Looks good. Now, I did make one small oversight. I should have checked the voltages of the batteries, or the voltage of the batteries, prior to doing this, and then afterwards, to see that there's a trickle charge voltage. But I think I'll still know, because I did enough testing to know what to expect here in terms of battery voltages. On their own, they were about 13 volts, which is surprisingly high. And now, Hmm. 12.62. 12.62. Okay, we're gonna have to simulate power outage. I'm gonna pull the plug out and we'll see what happens here. It should stay on. That's a thumbs up. It stayed on. So yellow light is on there. What does that yellow light say? What does the yellow light say? On. Can't quite see it. On battery. That makes sense, on battery. Excellent. So there we are. I've got my UPS set up. Now I just have to interrupt these different things to replug them back in, and I'm back in business. Great, and get back to working on some radios. Anyway, hope you found this somewhat interesting, and looking forward to more videos now. See ya.